title, The Race for Space, means the contest between the United States and the Soviet Union for propaganda. Our program will show that contest, and you will see American films and also Soviet rocket films never before seen by anyone outside the intelligence services. But more important, our program will show you that the race for space has always involved a great idea long before the Cold War, one of man's oldest stars. To understand why the dream of the exploration of space has so completely captured the mind of the modern world, you must let your imagination soar. Soar like a rocket. Imagine not only the white sands desert of New Mexico far below, but all the deserts of the world, like Africa's famed Sahara. Imagine all these deserts and all the other sandy wastelands of the world. And now realize that for every single grain of sand on Earth, there is a star in the sky. Think of it. For every single grain of sand, a star in the sky. Is it any wonder space is man's next frontier? Man's ceaseless striving to leave his own world and to explore other worlds. His search for other forms of life has always been his destiny, his greatest adventure, the real race for space. In 1898, the 20th century science of space travel was founded by this Russian schoolteacher, Konstantin Eduardovich Tsiolkovsky. There have been many Russian claims of firsts in science, but it's been authenticated that 60 years ahead of his time, Tsiolkovsky stated that the development of rocketry would lead to space flights. And in 1903, he designed and built this model spaceship. He also coined a new word for the artificial Earth satellites whose creation he predicted. He called them a Russian word for fellow travelers. This is modern Kaluga, Tsiolkovsky's birthplace, where today we are able to hear one of his granddaughters, Marie Samburova.
Дедушка выходил на крышу своего дома. Иногда к дедушке приходили посетители, начинающие ученые, корреспонденты.
Grandfather had many visitors, scientists, correspondents, and authors. Grandpa would tell them fascinating stories of how people would someday fly to different planets. All day long, he would work in his study making models of rockets. Sometimes on starry nights, my grandfather would go to the roof of his house and dream of the day when people would fly to the planets.
They were far more than dreams. Tsiolkovsky's ideas were the first scientific theories on space travel. It is interesting that it has always been these two nations, Russia and the United States, that have from the very beginning led the way in this race for space. For it was an American, Dr. Robert Goddard of Worcester, Massachusetts, who turned modern rocketry from a theorist's dream into an engineering actuality. Dr. Goddard began his rocketry researches as early as 1913, and in scientific circles he soon won respect. But it cost money, which he paid out of his limited salary as a college professor to conduct this historic test. In this scientific pamphlet, published just after World War I, he proposed using rockets to carry scientific instruments to the upper atmosphere and to the moon. We have with us today the widow of this great rocket pioneer, Mrs. Robert Goddard. Mrs. Goddard, your husband was a dedicated man of science, but I understand that after the publication of the Smithsonian report, many people called him the Moon Rocket Man. Now, I have here these clippings from the New York Times of January 12th and 13th back in 1920, in which the Times editorial writer implied that your husband didn't even know high school physics, and that his Smithsonian report was no more scientific than the science fiction novels of Jules Verne. How did your husband feel when he'd see articles like that?
Of course, this kind of publicity hurt, especially when it appeared in something like the New York Times. But he had spent many years working on the mathematical theory that underlies jet propulsion. He felt that the mathematics indicated that the predictions he had made, the things he looked for, were about to come true. Therefore, he did not let such things deter him from his experiments.
I think that our audience should realize, Mrs. Goddard, that you were the cameraman who photographed all of Dr. Goddard's great firsts in rocketry. Do you remember this historic shot?
Oh, yes, indeed I do. This was at Auburn, Massachusetts in 1928. It was one of the first flights of a rocket using liquid propellant. The rocket had become so large and the flights so long that we knew it was becoming dangerous to test them in any densely populated area. So we moved to Roswell, New Mexico, where this new test stand was built.
And it was here, not far from today's White Sands Proving Ground, that Dr. Goddard established many of the great firsts in rocketry.
During these tests, there was always so much to do, and never enough hands or time to do it with.
With this flight and many other successful flights, his rocket sometimes attaining nearly supersonic speeds of 700 miles per hour, Dr. Goddard established rocket history. During these years, Dr. Goddard developed the 214 patents that firmly established his reputation as the pioneering genius of the new 20th century science. Dr. Robert H. Goddard died in August of 1945 while serving as Director of Research in Jet Propulsion for the U.S. Navy. Mrs. Goddard, did your husband receive much recognition while he was alive?
From fellow scientists, yes. And also, in those days, it was possible to buy a copy of a patent for 10 cents. I understand there was a standing order for all Goddard patents. That standing order came from Germany.
Thank you for being with us, Mrs. Goddard. In post-World War I Germany, there were a handful of idealists who'd heard of Tsiolkovsky and Dr. Goddard and who believed in the dream of travel to the stars. The leader of this group was a distinguished theorist, Dr. Hermann Ober. He, along with a few others, formed the German Society for Space Travel. One of the most enthusiastic members of this little group was this 18-year-old boy, destined to become one of the giants of the American space program. His name, Wernher von Braun. Using some of Goddard's ideas and many of their own, the Germans experimented with the rocket in all sorts of ways. After many failures, they were learning what Goddard had already shown, that the greatest future for the rocket was in space flight. Like Goddard and many other scientists, the German Space Club members were in financial trouble and were about to disband. At this desperate moment, Germany's most distinguished motion picture director, Fritz Lang, came to their rescue. He was about to make the world's first modern science fiction movie, Frau im Mond, or Woman in the Moon. Would the club members serve for money as the movie's technical advisors? The answer was yes. You are now looking at actual scenes from this German classic produced in 1928. To make the launching more dramatic, Lang hit on the idea of counting backwards until the actual moment for firing. The German rocket pioneers then spread the dramatic notion of the countdown throughout the world. Most important of all, in addition to money, the Space Travel Club was also paid with all the props they could walk off with. These props were then used as the actual components in the Space Travel Society's rockets. But it wasn't long before the movie proceeds, too, had all gone up in smoke. And desperately, the club began to look around for a new source of funds. It soon marched on the scene. The German space fanatics wanted to get to the moon, Mars, Venus, the Milky Way. This German fanatic merely wanted to get to England. The Versailles Treaty had forbidden the conventional rearmament of Germany, but it failed to outlaw rockets because back in 1918 there was no such thing as a military rocket. So to the German Rocket Club, the Führer and his aides proposed a deal. The Army would finance all their experiments in rocketry, provided first priority was given to the creation of a long-range weapon. They had little choice. The Gestapo informed them they must assist the Army or be drafted to do the same work. This is Peenemünde, a remote fishing village along the Baltic coast. By 1936, the Nazis had moved most of the members of their German Space Travel Society here. They had installed them in these top-secret laboratories. Quickly assembling the leading technical brains of Germany, they appointed the youthful Werner von Braun as civilian chief of research. Von Braun had selected the site of Peenemünde and designed and built these tremendous test facilities. But now that the German travel scientists had bigger and better money and facilities, they had bigger and better failures. But soon there were a few successful test launchings. Propaganda Minister Goebbels gleefully named the new weapon Vengeance No. 2, or just plain V2. By 1943, the V2 was nearly operational, but occasionally one of the new birds would wander crazily out of control. One landed accidentally in neutral Sweden, and the wreckage was forwarded to the Allies. Another landed in Poland alongside a stream where the huge pieces were discovered by Polish patriots. That night, the Polish underground radioed the Allies, who immediately sent out a plane which brought the V2 wreckage back to Allied Supreme Headquarters in London. Now, with both the Swedish and the Polish wrecked V2s in their hands, the Allies quickly reassembled them. They now realized what sort of terror weapon they were up against, and that they had no defense whatever against it. The Allied High Command knew that if the Germans could build up a big enough supply of these rockets, they could destroy London, and so pulverize the English ports that the Allies could not use them for the invasion of France. Day after day, the Allied reconnaissance planes scoured the European continent. Luck was on the Allied side when an RAF patrol on the Baltic coast snapped an aerial photograph of the obscure fishing village of Peenemünde. At RAF Intelligence Headquarters, this photograph was developed and enlarged. One of the German terror weapons was plainly seen on a launching pad. The target for that night, August 17, 1943, was Peenemünde. 300 British heavy bombers took to the air. Plastered Peenemünde with 1,500 tons of high explosives and thousands of incendiaries. The August 17th raid shattered Peenemünde. The Germans were forced to quickly move much of their production equipment from Peenemünde to a huge new V-2 assembly plant in the East German city of Nordhausen. The scientists stayed behind to carry on their research in underground laboratories. But it was on the mad mind of Adolf Hitler that the massive Allied air raids on Peenemünde had their greatest effect. One night, he had a terrible nightmare. He dreamed the V-2 would never land on England. He quickly summoned Field Marshal Hermann Goering and confided his terrible dream to him. Then Der Fuhrer summoned the rest of his staff, and in a decision that could very well have changed the course of world history, Hitler signed the cancellation order for the entire rocketry project, effective immediately. What 300 British bombers and thousands of tons of high explosives could not achieve, Hitler, as the result of one bad dream, did. But at Peenemünde, when the army informed von Braun and his associates of Hitler's decision, they would not give up. In past moments of desperation, the space travel enthusiasts had made a movie. Very well, now they would make another movie. Furiously, several reels of film were put together, featuring only the successful rocket launchings. At staff headquarters, they set up a special showing of this carefully edited success story, and they persuaded Hitler and his aides to attend. And in what may have been history's most important motion picture preview, an audience of one saw the picture. Heard the voice of the weapon's creator, von Braun, serving as narrator. You are now watching the actual scenes taken from this historic film. No picture has ever played to a more receptive audience. With his mania for power, the very notion of a terror weapon from space he found irresistible. As he left the screening, Hitler uttered these prophetic words. "From now on," he said, "Europe and the world will be too small to contain a war. With such weapons, humanity will be unable to endure war." He reinstated the V-2 project with the very highest priority. Within a few months, the perfected rockets were giving live performances. To London goes the dubious distinction of being the first spot on Earth to be bombarded from space. The V-2 was indeed a weapon of vengeance. The invasion of Europe was now underway. But what of the V-2? In the words of General Eisenhower, if the Germans had succeeded in perfecting and using these rocket weapons 6 months earlier than they did, our invasion of Europe would have proved exceedingly difficult, perhaps impossible. The Allied armies swept through Western Europe. The hour of liberation had come. Germany was overrun. From the point of view of the German army in the spring of 1945, the V-2 was too little and too late. And soon the American army from the west and the Russian army from the east met at the river Elbe. But even before peace was declared, even as these brothers were in each other's arms, in the minds of their military leaders, not very brotherly thoughts were being born. The V-2 was ahead of its time. Though it had no effect on the outcome of World War II, it could very well determine the winner of World War III. It was at this moment that the race for space began in earnest, and there were two immediate prizes. The stock of V-2 parts at Nordhausen and at Peenemünde, the test equipment, and the juiciest plum of all, the brilliant minds who had made the V-2 possible. As the European war moved into its final weeks, the American army had advanced close to these prizes. But under the agreement for occupation of Germany, the United States would have to turn all this territory over to the Red Army. The American officer on the spot was Major General Holger N. Toctoy, then a colonel in charge of Ordnance Technical Intelligence in Europe, and now commanding general of the Aberdeen Proving Ground in Maryland. You had to act fast, General Toctoy. What did you do?
Our intelligence sources had told us of the role Dr. von Braun and his Army Superior, General Dornberger, had played in the development of the V-2 program. I believe that the brains of these men, if we could find them, must be put to work on behalf of the United States. After all, they were the world's only experienced missile team. I later cabled Washington and requested authority to search for and bring 300 of the leading German rocket scientists to the United States. I found I was championing a very unpopular idea. So before long, I was in the Pentagon pleading the case in person. I finally succeeded in gaining approval, not for the 300 German scientists which I had requested, but for only 100. This was the beginning of Operation Paperclip. At the same time, I ordered my assistant, Colonel James P. Hamill, then a major, to get to Nordhausen as fast as he could, and to move out enough V-2 parts to assemble 100 missiles before the Russians took the area over. Somehow Hamill and his men found enough boxcars and quickly loaded them with the V-2 component parts. When I returned to Germany, Hamill and his men had managed to get these boxcars and their precious cargo into the American zone 2 days before the Red Army moved in. In terms of the biggest prize, the brains who had built the V-2, we had previously received bad news. Our agents had gotten into Peenemünde, found the place stripped and in ruins, and the Red Army in control. There was no sign whatsoever of Dornberger, von Braun, and the other scientists. Terribly disappointed, we presumed that they were all eastward bound. We intensified Operation Paperclip. In some unoccupied areas, we had to parachute our specially trained agents in on the chance that some of them might still be found. In other places, we set up key roadblocks. We found some important scientists, but it looked like the ones we really wanted had slipped through our net. What we didn't know was that as the Russian army approached Peenemünde, von Braun and their colleagues had rounded up a few battered trucks. They loaded these trucks with plans, blueprints, and choice equipment. They headed for a retreat in the mountains of southern Germany, where they hoped to continue their work. Finally, when it became obvious that Germany had lost the war, they decided, in the words of von Braun, to go with the West. General Dornberger, the V-2 scientists, and Dr. von Braun surrendered. Dr. von Braun's arm had been injured in an accident while fleeing to Bavaria. With the surrender of these scientists and the large number of V2 parts in our possession, Operation Paperclip was a resounding success.
And so then you arranged passage of the 100 V2 scientists to the United States.
Well, actually I took 127.
Oh?
This was the least that I felt could form a completely integrated guided missile development team of truly experienced specialists.
What about the scientists themselves? Weren't there a lot of unfavorable publicity and other problems in bringing them here to the United States?
Yes, the President and the Congress were petitioned to return these so-called enemy aliens to Germany post-haste. But the United States had much to learn about rocketry, and these men, dedicated and experienced, made very fine teachers. So we stood firm.
Well, General Toftoy, I think our audience should know that for your foresight and dedication to duty and your successful direction of the Army missile program, the United States last year gave you its highest peacetime award, the Distinguished Service Medal. And we surely appreciate your being with us. Under Hitler, there had been 3,000 scientists, engineers, and workers at Peenemünde. Most of these men and the heavy equipment fell to the Soviet Union. But as a result of Operation Paperclip, the cream of the crop in brain power was brought to the United States. And so the first round of the race for space wound up a draw. The war was over, and both sides were starting out even. The troops had come home at a time like this, whose fun-loving country wanted to get back to normal, to home and family. These were to be the best years of our lives. From 1947 to 1957, there were 54 million new cars. There were 11 million new homes and over 3 million new graduates from American colleges. But what America was doing mostly during these years wasn't work, and it didn't require study. We were having babies, the biggest crop in history. 39 million births in 10 years. During the same years, 50 million TV sets were sold. And by 1948, this was America's best-known face. But from the world of Milton Berle to this other world, it was quite a change. Here in grammar and high schools, half the curriculum was devoted to science. The Soviet universities were especially booming, training each year 150,000 scientists and engineers, both men and women, compared to the United States' 70,000. The Soviets also tested thousands of their own newly developed missiles. These are the first publicly shown films of these Russian research rockets. With the knowledge gained from this rocket research, with a tremendous surge of new graduates from the technical and scientific schools, it was not long before new missiles rolled along the streets of Moscow. In the Union of Soviet Socialist Republics, there was a new look. In America, however, there were only a few dedicated men who believed in space, who kept working, kept persuading, kept patching together their missile programs with a little money and a lot of hope. During the early post-war period, as an example of their patchwork, they mated this old warhorse V2 out of Peenemünde, Germany, with this small young missile called the Whack Corporal, fresh out of Pasadena, California. The V2 Whack Corporal combination was America's first two-stage missile. It also marked for the first time the blending in action of American and German rocket brains, a combination that was destined, despite many setbacks, to have its rendezvous with history. With the firing of this missile and the subsequent development of such rockets as the Viking and the Atlas, America's missile program was finally underway. The Soviet scientists were especially interested in space medicine. They wanted to know whether a dog could survive in space where there is neither air nor weight, but only uncharted fields of deadly radiation. With a camera placed on board the rocket, the Soviets shot this actual footage of their dogs in space. The dogs are here experiencing weightlessness, as is shown by the free flight of the loose bolt in the foreground. This bolt is completely weightless. The dogs returned unharmed. The Soviets were not secretive about their intention to create Earth satellites. With increasing frankness, they discussed their plans with anyone willing to listen or read. And Premier Khrushchev himself, in August 1956, officially announced the Soviet development of an intercontinental ballistic missile with a range of 5,000 miles. If the Soviets could send up such missiles, they could also send up Earth satellites. The target date was 1957, the International Geophysical Year, a United Nations scientific study of the Earth. The Russians announced that sometime in 1957 they would send up their Earth satellite. The United States, too, promised to launch an Earth satellite. But in our satellite program, we Americans got badly bogged down. Why? What happened? We had the money, the resources, and the scientific know-how. Unfortunately, a series of wrong decisions led us to frustration and failure. We present the following facts to salute the men who understood the importance of space. The failure to heed the advice of these men irrevocably altered the world situation and brought about America's present position in the race for space. Now we present these facts, facts based upon sworn testimony before the United States Senate. It is a fact that the United States could have fired the first Earth satellite as early as 2 years ahead of the Russians. By 1955, the scientific team under General Tolstoy and Dr. von Braun had developed a new military missile called the Redstone, which was highly successful. They proposed that a modification of the Redstone, called the Jupiter C, launch the promised American satellite. At the same time, there was another proposal that a brand new rocket, the Vanguard, be especially created to launch the Earth satellite, even though with a new rocket there were far greater chances of failure. The untested Vanguard was chosen on the grounds that the satellite should not be launched by a military rocket like the Jupiter C, but rather by a purely scientific device, since it was to celebrate a United Nations event. Knowing the odds were high against the Vanguard's success, General James C. Gavin, Army Chief of Research and Development, Generals Tolstoy and Medeiros, Doctors von Braun and Pickering, and many others, kept begging for permission to launch the satellite with the Jupiter C immediately. They were fearful the Russians would launch theirs any day. Each time they asked, they were turned down. Then, on July 29, 1957, this order went out to the armed services. Let me read it to you. Recent news stories which have described certain projects as space flight projects have resulted in unfavorable reaction at Department of Defense and congressional levels. In any speeches or public releases planned by you or your staff, avoid the mention or the discussion of space, space technology, and space vehicles. And so, by the summer of 1957, space had become a forbidden word in Washington. As autumn came in 1957, most of the men who believed in space were silent. Throughout the country, the long, hot summer was over, and the children had gone back to school. In Washington, the space program was bogged down in frustration. But in the Soviet Union...
3, 2, Один, стреляй!
There are dates that school children in the United States are required to memorize, like October 12, 1492, when Columbus discovered America. Now there was a new date for Russian youngsters to remember. October 4, 1957, when Sputnik, the first Earth satellite, was launched. The new moon circled the globe every 96 minutes. All the people on this fast-shrinking planet heard about it. Many of them watched it. All of them read about it. In the history of the Earth, no other event had captured the imagination of so many people as this first step into space. At least the word space was now legal in Washington. There were high-level meetings. There were press conferences and sober analyses of the nation's new position. There was prolonged national soul-searching by the executive, by Congress, and by the military. Meantime, the Soviet Union was ready to launch its second punch in a row, Sputnik II. Aboard this new satellite, Laika was to be the Earth's first traveler into space. Here is Laika in his capsule, which will be placed inside the satellite. There were instruments to test his reaction to cosmic rays, radiation, heat, cold, and weightlessness. In these exclusive Soviet films, Sputnik II is shown in its pre-launch preparation. The Russian satellite weighed 1,120 pounds, 10 times heavier than the first Sputnik. On November 3rd, 1957, commemorating the 40th anniversary of the Russian Revolution, the Earth's second artificial satellite went into orbit. The second Sputnik was not only a tremendous scientific achievement in itself, but in the information received on Laika's long flight into space, the Soviets gained a priceless advantage in any forthcoming race to put a man in space. In desperation, the United States looked to the vanguard. Nearly 200 newsmen from all over the world were flown down for the big turkey shoot. At the launching site, they were given a play-by-play account. They witnessed each tiny detail of the usually top-secret preparation. It was carnival time at Cape Canaveral. All through the day and night, thousands of people thronged the nearby beaches and jetties, waiting eagerly for the big moment. And inside the blockhouse, the tension steadily mounted. America's prestige had never been lower than at this moment, 11:45 a.m., December 6, 1957. At Huntsville, Alabama, Major General John Medeiros, Commander U.S. Army Ordnance Missile Command, had called a special meeting.
Good morning, gentlemen. Be seated, please. I have a very important announcement for you. We've been assigned the mission of launching a scientific Earth satellite. And we will use the Jupiter C configuration as a carrier that we developed along with the Jet Propulsion Laboratory. I promised the Secretary of the Army that we would be ready in 90 days or less. Let's go, Werner.
For years, they had begged for this chance. The deadline was 90 days. But to put up a satellite within 90 days would require an unparalleled crash program. The work was divided into three vital areas: the rocket carrier, the instrumentation, and the upper stage scientific payload. Each had to be redesigned, rebuilt, and each had to work right the first time. Here at Huntsville, Alabama, the rocket carrier development program was the job of a crack team of over 3,000 scientists, engineers, and technicians, headed by Dr. Werner von Braun. At the State University of Iowa, Phase 2, the instrumentation. Its development was under the direction of Dr. James Van Allen. He had already designed some of the complex electronics instruments that the Vanguard was supposed to have hurled into orbit. Having anticipated a possible Vanguard failure, he had designed his instruments so they could also fit into the tube-shaped satellite that the Jupiter C would carry into space. At their 150-acre research and development complex at Pasadena, California, Dr. William Pickering and his associates were racing toward the same deadline, 90 days to put a satellite in orbit. Their job, Phase 3, build and package the rocket's upper stages that would take over once the Jupiter C had lifted the satellite into space. Assembled, the satellite appeared small. But if all went well, 7.5 minutes from the time the giant missile bearing it would leave the Earth, the cylinder, now called Explorer 1, would be hurtling independently through space at a little over 18,000 miles an hour, if all went well. Cape Canaveral, Florida, Wednesday, 29 January 1958, 8 days before the deadline. The Jupiter C was on its pad in position for launching. But on the morning of the 29th, the weather was unfavorable with heavy thunderstorms and jet streams aloft. A 24-hour postponement was decided upon. Friday, 31 January, the weather is clear. General Medeiros orders launch at 10:30 that night. Dwarfed by the giant carrier rocket and the gantry, the Explorer 1 satellite is carefully fitted into place, like a glittering jewel in a metallic setting. At X-2 hours, hydine, an exotic and explosive fuel, begins to flow into the tanks. Minutes click past. The beams of powerful searchlights light up the missile, truly the star of one of the greatest suspense dramas of our time. Time, late evening, Friday, 31 January 1958, in a blockhouse at Cape Canaveral, Florida. Here is the actual countdown for Explorer 1.
Roger. Okay, we'll start now. Finish fuel loading.
The man directing the countdown is Army ballistic engineer Robert Moser.
Okay, check the utility room fuel vapors and notify the blockhouse when we're clear to start generators. Control voltage on. 2.5, program device on. Gyros on. Check that launch loading has been completed. Roger. Connect assembly to igniters. Okay, tie down the lead. Roger, and install your protective tabs. AFMTC telemeter calibration tape on. Check all operating lights and meters for proper operation. Power panel check. Power panel okay. Control panel check. Control panel okay. Roger. Measuring panel check. Measuring panel okay. Power transfer test on. Observe and record all voltages.
Power transfer test on.
Western clear for launch?
Clear to launch. Bob? Yeah. 021, deflection of jet main number 2. We've either got a relay kicking out or there's something dropping down on the jet main instantaneously here.
Hold. Telemeter indicates the jet vane 2 is deflected.
This is Army scientist Dr. Kurt Davis.
What do you want to do?
Forget it.
Okay, resume count.
Okay, shall we go ahead, Jim? It looks like it. Roger.
Destruct arm.
That's complete.
All right, give me range safe, pad safety. I don't have it yet.
Range safe. Range safe.
Minus JPL telemetry recording on.
Telemeter recording on.
JPL recording on? Yes. 20 seconds.
Frequency 111, Terry. Roger, Joe.
15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Firing command.
Firing command. Fuel tank pressurized. Launch tank pressurized. Missile power. Ignition. Base stage. Lift off.
Lift off. The missile is in flight, but the success of its mission is still in doubt. It will take another hour and a half to know whether the satellite is in orbit, and this is the most tense and agonizing wait of all. Midnight. General Medeiros calls his assistant, Colonel Leonard Orman, who has kept a direct line open to the Secretary of the Army.
Hello, Len. You can send this off to the Secretary. That our satellite is definitely on orbit. Now get that off and then...
In Washington, a new kind of American hero was born. Men like Pickering, Van Allen, and von Braun, with the scientific ability, foresight, and determination they had shown, were to lead America into the new age of space. This dedicated team had lifted our first satellite into orbit. In the contest for space, the race was by no means tied up. The Soviet Union, with its tremendous heavy satellites, was still ahead. But the United States was definitely in the race and ready for the next challenge. We'll be back in a moment with the concluding scenes in the race for space. Now, Soviet science has rocketed to the moon. These are the first actual photographs of its hidden face. And American satellites, from the Vanguard to the Pioneer, have given us priceless information as well. But the new contest is the race to put a man into space. These are more than science fiction films. Produced by the Soviet government, they are the actual Soviet blueprints for their space vehicles of the future. Now both sides had shot satellites into orbit. Soon there were to be many more satellites, heavier, with more complex and advanced electronic equipment. But there is no collection of electronic tubes as complex and as advanced as the brain of a man. This was to be the next contest, the big contest, the race to put a man into space. For space is man's new frontier.
the exploration of other worlds, the search for other forms of life is man's destiny. And his great